Hello, and welcome back to TubaFix. My name is Nathan. Today on the video, I'll be reassembling the tuba after having cleaned a lot of the parts, slides and valves and so forth. And then we'll see if we can't get it to the point where we can figure out what's missing and what we need. Plus, I include a little information about how valves are constructed and how I'll have to be approaching the engineering task of engineering the third valve replacement. So let's buckle in and see if we can't get this old girl put back together at least a little closer to what she actually should be. Well, as you can see, I've been spending time trying to clean these parts off. So we have the various slides have been brassoed on the contact surfaces, and I just got them out of the soapy water, in which I have tried to clean all their surfaces as best as I can. I have not gone and done a lot of detail work on this yet, and the reason I have not is because I'm going to wait till I get this all together. I'm going to grease up these parts and get them reassembled so I can try playing the instrument. Then I'm going to work on the fabrication of the third valve and getting the instrument whole. When I get all done, because I presume there will be detritus and dirt and stuff from the manufacturing process, from the testing and the prototyping, that's when I'll actually turn around, disassemble everything, re-soak it in water and soap again, clean all the parts very, very thoroughly, toothbrush the whole thing, then finally reassemble it into an instrument that we can have in a working condition for permanent. This is a temporary measure to get everything clean enough to be in a working order and accept the grease and get the corrosion off, not to get 100% perfect. Look how shiny and clean this valve is. It's disassembled. I took off the valve stem and the padding from the top. You can see the padding over here. It consists of a cork pad right there and a felt pad as well. Those all get replaced during the course of this project just because they're old and worn and they're overdue to be replaced. But I'll replace them for now because I don't have anything else. The valve stem itself consists of a round brass plate with the stem itself going through it. It's thread into the top of the valve. This gives us an opportunity to examine the valve a little more in detail while I have it out before I insert it and it's all oily. So valves, curiously enough, are hollow, which is not something that you inherently think about until you think about why. So there are a couple of reasons for this. The body is hollow, and I don't mean, when I say hollow, I don't mean just because it's got holes drilled through it. That's not what I mean. It's actually hollow inside here, inside the actual body. Two reasons. One, for weight. You don't want a lot of inertia and a lot of mass to be jumping up and down on the spring. You don't want a gigantic spring in there and a really hard action to push it up and down inside the instrument. So it has to be hollow to keep the weight down. However, number two, which is probably just as important, if not more, is that the tolerances between the valve and the valve casing itself are very, very small. They generally try to keep them around 0.01 inches or so, which I'll translate to millimeters here at some point. But because those tolerances are so small and there's a thin film of oil on the outside of the valve that rides between the valve and the casing itself, which is really close to here, you have an airtight seal. Well, the valve is going up and down. The air has to go somewhere. And so what they do is the valve stem threads into here, but this is an air hole. It allows air to bypass through the valve all the way through the hollow body and out the bottom of the valve, or vice versa, depending on the direction of travel. This actually ends up being very advantageous towards the action of the valve so that you don't have a pressure buildup on either side and the action is smooth. To construct the valve, they take the hollow pipe, drill holes at the appropriate locations, cut pieces of brass pipe or similar nickel plated pipe, push them through the body into the holes that were drilled, and then solder them in place and sand them down. This results in a nice smooth edge that drifts nicely up and down inside the casing, and the tube connects wherever it needs to connect through here. However, that presents a bit of an engineering task when we come to actually trying to fabricate a valve, because I have neither the grinders nor the soldering skills that these folks do, and it's usually set up in a jig that's specially designed for this. But that is part of the adventure. I'm going to have to figure out what to do about that long term. Short term, we use wood or plastics or some other materials to replicate the valve so that we can get the general idea and get the placement right. The long term valve replacement will require a bit more ingenuity. The next step before I can try playing this beast is to actually figure out a way to cap off the ends of the third valve so that I can blow into it and not have this bypass. So now that we have the tuba reconstructed, we're going to have to get into playing it. I'll save that for the next video, but soon we'll give it a shot and see if we can't make some music. Along the way, I have a strong feeling we're going to have to troubleshoot a few issues. Thanks for watching, and tune in next time when we continue this curious and wild little project. Thanks.